Okay, let's get started with solving this Leetcode number 53 maximum subarray problem. So what does the problem state? Given an integer array nums, find the subarray with the largest sum and return its sum. So we have provided with this value the array, and among all the subarrays of this array, what we have to compute the subarray with the largest sum. So this is the problem, and it's medium problem, and it's basically based off an algorithm, Kadane's algorithm. I'll come to that. So let's just think of a brute force approach, what the problem is being stating. So if you see, let's brute force is simply, let's just do what is being asked, subarray with the largest sum. So we'll get started with considering all the subarrays and then computing the sum. So if you see this example here, what we will do is we will compute all the subarrays. So for computing all the subarray, if we get started with index 0, so starting at the index 0, this is one subarray having -2, then this is another subarray with -2 and 1, this is another subarray, this is another subarray, and this is another subarray, and so like that, so there are multiple subarrays starting with index 0. Now similarly, starting with index 1, there would be another set of subarrays, like this is one subarray, then this is another subarray, then this is another subarray, and so on. Okay, so in that way, what we will do is we will consider all the subarrays, so we will be able to have all our subarrays. Now I know that, okay, if I have this one pointer I, which basically tells me what is the starting point of this subarray, and I have this j pointer which tells me what is the ending point of that subarray. Now I could have another pointer k, which could iterate over this length I and j as a start and ending point of the subarray and calculate the sum out of it. So what will there would be another loop for computing this sum, and altogether I would have the sum for each of the subarrays, and at the end I will keep a maximum variable which will have the maximum variable at all the times, and at the end I'll be having the answer for my subarray with the maximum sum. So if we go with this, if you see, like, there will be one loop where I will start from 0 and go till n, then there would be another loop where j would start from I and it will go till n, and then we would have another loop, that is k, which will start from I and it will go till j, and we will have a temporary variable sum that will have this value 0, and we will just keep adding this sum value. Okay, this is sum plus equal to this nums of I, and once this sum is computed for a particular subarray starting with I till j, what I will do is I will have this maximum variable, that is max sum, which will tell me the max of max sum comma sum that I have computed, and in that way I will have the answer for this. But if you see, we are having this 3 loops altogether. So if you see the time complexity for this question would be for this approach is, since we are having 3 loops, it's O of n ki power 3, and space complexity, since we are just having some few variables on the way we have taken, so it's constant space complexity, so it is a constant space. But if you see in the question, the constant that we have been given, it is like clearly 10 to the power 5, and with the length of the array can go till 10 to the power 5. So our approach is not going to work over there. So for that case, because it would be 10 to the power 15, so it won't work. So in that case, we need to do some optimization over here. Now if you see this sum calculation part, this could be avoided. So for while moving j, if you see, while moving j was initially here, okay, then we moved here, then we moved here, and then here, and so on. So while moving j itself, we could have computed a variable, you could have this sum, and we could have computed the sum value. So that would have considered, okay, till this length, this is the sum, and this is the variable. Then j is like till here, so this is the running sum, and so on. So in that way, we would be able to have this calculating sum part removed, this part basically. So this is a little optimal from the above, where we are still considering the subarray, where we are still considering all the subarrays, but keep computing sum on the way. Okay, so instead here, if I just do this, okay, so if I just do this, and here if you see, we don't need this, okay, so I'll just remove this, and here we can have this sum equal to 0 and sum plus equal to nums of j, okay, and we have calculated this sum, so max sum equal to max of max sum comma sum. So in this way, while going on the way itself, this is our subarray itself is considered. So I is here, j is here, okay, this is my subarray of this length. Now my I is still here, my j goes till here, so this current sum would have computed till here only, right? Now since I moved my j here, sum has added this value also, so now this is this sum. So at first we have considered this subarray, then next we considered this subarray, then I'll add this value, so now this is my another subarray, okay. So instead, not outside, basically this need to be inside the loop, yeah. So every time we are having this new subarray, and new subarray, so we are getting the sum, and every time we are having the max out of it. So this is the little bit optimized of above approach, but here also if you consider the time complexity, right, we are still running two loops over here, so time complexity would be of n square, and space complexity would be, it's constant space, right, we are not using anything additional, so it's O of 1. Now if you see the constraint again, right, it's 10 to the power 5, and what we have did is n square, that is 10 to the power 10, that is still not going to pass, it's the more time that we are going to take. So we have this is not the most optimal approach for the solution. So here comes the most optimal approach for this solution, that is basically Kadane's algorithm, okay. So for what is basically this Kadane's algorithm, so here you have seen that we are computing considering all the subarrays and then computing answer and so. But if you just think of it, like for example, if this array didn't had any negative value at all, so it would have all positive, right? So for that case, we didn't need to do all of this, right? Because if the array is all positive, we can just sum up all the values in the array, and that would be the subarray with the maximum sum, right? Since these negative values are the ones which are reducing the altogether sum of this any subarray, these negative values are the culprit ones, right? So what we need to consider is, let's say if I have computed sum till here, okay, and it comes out to be negative, then just think, if I add this value into my upcoming subarray of any, let's say this value itself, this is negative, if I am going to add this into my value, this total value, whatever it is, it's being 0, positive, negative, if I add a negative value to it, it's definitely going to be this value is definitely going to be decreased, right? So it's always going to decrease its value. So what this cadence algorithm states is that if we come a value that is a negative, rather we would consider as a 0 and we would start fresh. Okay, so I'll just do a dry run on that. Okay, so it is, let's say, current sum is equal to 0, and we can have this max sum. There is one edge case that I'll come to at the end, but here if you see this negative value, the max sum can be anything. Usually if we are considering this maximum value, we should take the negative, least of the negative, that is nth min. But I would explain like why I'm not taking that. Rather, I would take the first value from the array. So it would be nums of 0, which is basically -2 in our case. Okay, now here comes, I am at 0 index. My current sum is -2. Okay, I'll update it to -2, and I'll see if my maximum sum is updated or not. It's not, but since I see this is negative, I would change it back to 0 because this is not going to add any value. I'll move my pointer next. It comes here at 1. At 1 I see my value is 1. I'll add it here 1. I'll compare again. Okay, my value is now updated, it's 1. Now I'll move my pointer ahead. Here it goes to minus of 2, adding -3 with 1. -2, it's negative, so I'll make it back to 0. And it's not, -2 is definitely less than 1, so I won't update here. Now I move my pointer here. It's adding values 4, so it would become 4. Now I come here, so it would be maximum value also I would have updated. This is 3 is definitely less. Now I come over here, it's 5, so I would update 5 here also. I came here, it's 6, I update here also. I come here, it's -5. So for -5 I would -5 is like 1. Don't update the value. We are good, we can go next. It's 5, it still don't update the value. So at the end we get this maximum value as 6. So if you see this, the core part was, if we add the running value in our sum, if it is negative, we take it back to 0. If it is negative, we take it back to 0. Okay, so that we are not adding the negative value in our total sum, and meanwhile we are keep updating our maximum sum. Okay, so this is the algorithm. Now I can okay, so now let's code this out. This is the same problem, and here if you see, I have taken the largest sum as int min and current sum as 0, and I'm iterating over this array, computing the current sum every time, and then adding this computing this maximum sum, largest sum every time. And in case if my current sum is negative, I am taking it 0, because we don't want to have this negative value adding to our subarray, which will definitely decrease the overall value of the subarray. And at the end we are returning the largest sum. So this is the very simple and straightforward code for it. Just the core part was, for this problem, core part was this. If it is going to be negative, we don't need to consider it, and otherwise we are all good with that. So I can just run this, and yeah, the run result is all good. We can submit it. Yep, all test cases are passed and we are good with this problem. I hope you like this video, and this was my very first video, and there is going to be much more that I'm thinking to record. So stay tuned, I'll definitely post something tomorrow. Thank you for watching.